Weekend देखा start.
So now we will start the second session of this activity. So I welcome you all to the second session of the day 1 of the FDB Convergence on AI and IoT for Smath. So, ladies and gentlemen, it's my pleasure to introduce the today's session speaker, Dr. B.S. Harish. So Dr. B.S. Harish is a professor in the Department of Information Science and Engineering at Jesus Science and Technology University. He received his BE in the Electronics and Communication in 2002 and MTech in Networking and Internet Engineering in 2004 and a PhD in the classification of large text data in 2011. So his research interests are includes in the machine learning, text mining, and the computational intelligence. So he has 100 plus paper publications in various journals. So beyond his academic credentials, he is involved in the professional community also. So he is a life member of an actually INSTCC, so IENG, ISTE, and various. And some of his research projects includes recent projects includes a project on machine learning in the automated Kannada text recognition funded by the Vision Group on Science and Technology and Government of Karnataka. So he has also received several awards for his research. Few are the first band in the Unconstrained Peer Recognition Challenges 2009 competitions and first place in recognition task in the scalar segmentation and eye detection benchmarking competitions. So I hope this presence will enrich our learning experience and ignite a new ideas within us. So please join me in giving a warm welcome to the Dr. B.S. Harris. I request Hannah sir to hand over a okay to welcome you. Sir, we welcome you to the activity. Thank you, sir.
Let it be a very unconventional presentation. Okay, so I see that some students also equally students are also interested in attending this. So I request some of you to occupy the front seats because I'm not going to use the mic. Right, so probably the amplitude of my voice will increase definitely. And don't worry, I won't ask any questions because even I don't know the answers to most of the things. Right, but the only thing is preferably the other participants who are the teachers. And so, you really comfortable listening in that, it's fine. Otherwise, if you're okay with this, Madam, madam, can you come in?
ರೆಡಿ ಮಾಡ್ಕೋಬೇಕು ಇಲ್ಲ
Don't worry too much. I won't ask any questions. Even if you are feeling sleepy, I'll always ask. So that is the best part of attending an any class. Alright, so am I audible? We need to like if you open the window, that is no, because the weather is very pleasant. Right, so very pleasant. So thanks for the opportunity, firstly, for giving me to share some of my experience, uh, which has been done by my students, not by me. So I just only supervising some of the best works that are done by my students, and very interesting topic of convergence of AI and IoT for smart health, right? So we try to take up, we split the title into different terms: AI, IoT, smart health, and then we spend at least a minute or 2 minutes of time in understanding what is AI, what is IoT, what is smart health, right? So why it is called as a smart health? Right. So I think if you see now, there is nowhere we call it as only as a bit, right? So we call it as a smart health, right? So why it is called as a smart health, right? So before starting the session, some of the very fundamental questions. I mean, it's not the technical questions that I'm going to ask. Right. So some of the very basic questions that I wanted to know is. Uh, since some of them are the teachers from the different institutes also, how many of you are very comfortable with machine learning? So you are very comfortable with machine learning. So yes, machine learning, artificial intelligence, or any allied subjects also looks fine. Data mining, it could be artificial intelligence, machine learning, neural networks, computational intelligence. Okay. So, how many are okay with the basics of machine learning? Basics, very fundamentals. Just to define what is machine learning. If any person come and ask you, just to define what is basically a machine learning. Right. So, just to define what is basically machine learning and why it is called as a machine learning and what are the different types of machine learning. How many of you are comfortable with this? Okay. So, most of the teachers are fine. Right. So. Okay. How many of you are comfortable in answering the different types of machine learning techniques? Different types of machine learning techniques. I mean, this is not applicable for those who have not answered or doesn't know the basics of machine learning, but at least the different types of machine learning. So different types of machine learning. And there are many ways of learning the things. So we just try to explore how these concepts, right? So that whatever we are going to discuss for another, 120 to 150 minutes, right? So it will be for 120 to 150 minutes of time. We try to, take from the basics, which are very fundamental, right? So these are very fundamental because probably, I think Dr. Yes, Manjunath will be coming on the later later days, probably in weekends, Friday or Saturday. Dr. R. Dinesh will be, that is what I got from Dr. Sharad. I think they'll be speaking at the very higher level of machine learning. Right, so maybe if they speak, you should not feel that you're getting bounced. Right, so you're getting bounced. But this is the one topic, right? So which is really taking a lot of importance in most of the domains, right? So in most of the domains, right? So because if you have seen the NCERT syllabus, right? I'm talking about the fundamental classes, the fundamental classes of class 8, class 9, and class 10. If you take the NCERT syllabus, right? So there is a skill-oriented subject called artificial intelligence where the students will study the artificial intelligence from class 8, class 9, and class 10. Right. So why is that is needed at the level of class 8? Right. So why it is needed at the level of class 8? Right. So why we have given so much of importance to that what we call artificial intelligence and IoT and all we take at the later stages. Right. So they are all as I said they are all kind of the different domains just to integrate it to make our life very simple. That's all. Right. So other than that, nothing big deal. And whatever we are going to discuss, probably if I just I took hardly 2 hours of time. No, I have said, oh, you need not to change. I can change it. Right. So if I just see the slides that I have presented here, right? So I took not more than an hour or 1.5 hours to prepare these slides. But if I present these slides, it will look like especially for the beginners, right? So especially for the beginners, it will look like that you are watching an German movie, Italian movie, right? So there you cannot you won't understand anything. Right? So it's full of bones because of a lot of mathematical equations, right? So a lot of mathematical equations, lot of variables, right? So and at the end of the day, you feel so frustrated, right? So the tool is kind of an weather, and the tool is after having, as Professor Shiv Prasad said, having a nice lunch, right? So sitting for 120 to 150 minutes and seeing such kind of slides, I think it will be tremendous, right? So I don't think so that is acceptable with the students, but definitely not with the teachers, including the lecturers. Right. So because teachers, who are less, they are always, they try to be, I mean, including myself, right? So they'll always try to be, going in an one-way communication, right? So especially in these afternoon sessions, speaking, engage with the students itself very well. So as I said, whenever you find something that is out of your mind, you just stop it, right? So I'm trying to get a clarity, right? So and what I'm going to present today, it's nothing much that what we have done something which doesn't exist in this world, because we being doing the calculations, right? So or the schooling for the different levels, right? So we see the different perception of understanding the things, right? So a very simple example, right? So and whatever when people are talking about artificial intelligence, machine learning, data mining, right? So and people are talking something about big data analytics, IoT, and all. They're all very fundamentals, right? So if you just open your class 8, class 9, class 10 textbooks, right? So and if you see and you can really appreciate that why you missed those things getting in class 8, class 9, class 10. And that is what actually we have exploited here, right? So that is what actually we have exploited here. And you get to know, right? So there is nothing much, right? So what we are trying to put in a different way, that's it. Right? So that's all an any researcher can do. Right, so and that's all and any computer science underlying, that's all and any computer science engineer can do. Because there is as such, there is no any invention or discovery in computer science. Really? Really? How many of you don't agree with this? How many of you don't agree with this? There is no as such any discovery of the inventions that we are going to make. Right, so that is why there is no Nobel Prize for computer science. You find any Nobel Prize winner in first of all, there is no, there is no admission of computer science applications for the Nobel Prize itself, because right, so clearly categorized as such, there is no invention or the discovery in the field of computer science. So only the applications. Right, so that is why the students will enjoy like anything. Right, so reading artificial intelligence, especially at the class 8 and class 9 and class 10. So that is why that they are introduced, and that subject is called as a skill developer subject. Right, so that subject is called as a skill developer subject. What did Dr. M.S. Dinesh, or the M.S. Dinesh was say? What did he speak in the moment? M.S. Dinesh, the first speaker. Okay, what did he speak? Okay. Okay. So he spoke legal. Clinical decision support system. Okay. So I think he has not touched anything that is core technical. Then I think we'll try to start with this very fundamental, session. Right. So which I take you to some of the learning concepts. Right. So learning concepts, and slowly I take a deviation towards the first word in my title. Right. So first word in my title. Right. So then I try to spend at least half the time. Right. So in just making tutorial. understand what is clustering, right? So in understanding what is clustering, and then I will take up the second part of my title. Right, so the second part of my title basically it contains three words. Right, so basically it contains three words. One is medical, right? So medicine, in general it's medicine. So second one is the image, and then the third one is analysis. Right, so and then we'll try to see how whatever the things that you learned in the first half, right? So maybe the concept of clustering, right? So can be applied over the images, right? So in specifically, which are medical images, right? So how we can apply the concept of clustering to do the analysis of the medical images. Right, so this is what actually we are going to discuss for another 120 to 150 minutes of time. Right. So before getting into this, right, so the very technical things. Uh, First, we need to understand what is basically learning. Right. So I think there are 50, 40 participants here in this call. Whatever the number, right? So 40 to 50 members are sitting in this classroom. If I ask a definition, can you define what is learning? Right, so I can expect 50 different types of definition. Earlier I said. Earlier I said. So that is very challenging. Right, so why it is gaining a lot of popularity where I machine learning law because of this reason. Because of this reason, right? So understanding the definition of learning itself, you can take or you can frame nearly 50 different types of definition. Which you just imagine what should be the best definition that you can arrive at in defining the machine learning. Right, so I mean, only learning. Right, so only learning. So that is why it is considered to be an very interesting topic. So that is why it is getting in lots of popularity. Right, so in generally saying what is learning, any one definition, maybe you can just throw something. Any one definition, any one definition. New information. See, that is his way of understanding. Getting new information is learning. That is his way of understanding. Right. So I am not talking anything which is very technical. Right. So I am not talking which is very technical. So when he said something, getting information is basically a learning. Right. It is a process. Right. So Madam says it's a process. So is there any end for that process? It is another challenge. See, challenge number 2. Challenge number 2, there is no end for the learning process. Right, so there is no end for the learning process. Right, so and another definition, maybe the last definition.
This is of understanding and believing that.
Okay. So we are talking at the level of application. Acquire information. Okay. So as you said, acquire information. Process doesn't stop. The process doesn't stop. Any other any other definition that you can think of? Learn from? That is the way of learning. That is the way of learning. Right, so that is the way of learning. But the definition of the learning, right, so process of learning, so that is another one challenge. The learning, defining learning itself is another challenge. Right, so learning itself is another challenge. Process of learning is another challenge. So you just go on giving the definition. Each and every definition has got its own challenges. Right, so each and every definition has got its own challenges. Give you a very simple example that you might have seen in most of your home. Right, so if you see the kid going to the kindergarten, so probably you are having the kids might have experience, or probably your brother, sister, kids, right, so who are at home might have experience. They go to the kindergarten. Right, so they go to the kindergarten and first character that is going to learn at the school at the age of probably 2.5 to 4.5 years is the character A. Right? So maybe in some schools it could be R, so you can we take English. Right, so character A. How do you teach the kid which is of age 3.5 to 4.5 years. Right, so that to recognize it. So that's what actually madam said. Right, so that's what actually madam said. Right, so why madam knows? I mean, nobody can think of. You ask this group, do you know that there are something called slant lines? Madhuvai idea. Right. So do you know something called there is some sleeping line? Huh? Nothing. Okay, you conduct tuition, so that is fine. So you are getting kids, right? So you are getting kids, so that is fine. See, you pay from 3.5 to 5 years. You must have to whatever the different ways that you are going to write. Your kid doesn't accept unless otherwise it is being told by your teacher that this is the character here, right? So it's as simple as this: two slant lines and one sleeping line, which will make day. But you say the same kid at the age of 10 years. What is the way that it is going to write? The character A. Right, so it writes its own way. Right, so it writes its own way. There is no any kind of strong inclination itself that you are going to see. There is not at all any strong inclination that you are going to see in writing the character A. Right, so it takes its own way. Right, so how? Right, so why madam suddenly so within seconds she has replied, sir, two slant line and one sleeping line because of that matter. What she said was she had that experience. Right, so she has that experience. So this is how actually the learning takes place. Right, so this is how actually the learning takes place. And why computer science there's no Nobel Prize is because of this. Right, so it's because of this, because see once again, if you same thing, if you teach your machine is nothing but your computer machine, or even it could be your Android devices, or it could be a living machine. Right, so it does on the same thing. It learns on the same. Right, so it learns on the same. So for example, I think you might have heard at least a terminology called character recognition. Character recognition. Right, so you know what is basically a character. Right, so if you write 2, your computer machine will tell that is 2. If you write 3, your computer machine will tell that is 3. Right, so in that sense, it is learning by itself. But what is the basic for that? The basic is nothing but our right, so that how exactly we think. Right, so that how exactly we think and how exactly we are going to apply that. Right, so yes, there is a prize, Nobel Prize, right? So to tell that how your brain is learned, but there is no Nobel Prize, right? So there is no Nobel Prize, right? So to tell that how your machine has learned, because whatever your brain or however your brain is going to learn, the same thing is related in the machine classifier. So somebody said just apply it, right? Somebody said it is apply. So that is why it is called as indicators. Right, so that is why in most of the engineering discipline I can say in front of anyone, the simplest program that you can find in the field of engineering is Python. Computer science. The most simplest program you can find in any of the B program is the computer science. It doesn't need any specialization. It doesn't require any kind of foundation. It doesn't require any kind of the more the advanced subjects, right? And very interestingly, learn by yourself. Computer science is always learn by yourself, right? So and to see so much of data that are available, right? So and with that we can do wonders, right? So and that we can do the wonders. So that is how actually that is why computer science is gaining a lot of popularity. But world is so simple, but you cannot imagine the impact that it is creating every day. Right, so every day. Right, so every day is creating a lot of impact. Right, so and you cannot really imagine. Right, so you cannot really imagine your life without computer science. Right, so you can say so many things. No, sir, I'll be like this, sir. I can do, this kind of meditation. I can do yoga. I can promote of all these things. Right, so you can do all these things, but ultimately at the end of the day, definitely one or the other, it will land into technology. Right, so that is the penetration. Right, so what is the first thing that you do as soon as you get up? The first thing that you do is always you just see your mobile phone. Right. So and what is the last thing that you do? You mobile phone. Right. So your day starts with it. Mobile phone and your day ends with it. Mobile. Right. So that is the level of penetration. And can you imagine your life, right? So even if you forget book, you won't really go back to your own. Right. So at least you can ask your friends to give a sheet of paper and you write the notes. So you just imagine you forget your phone. Right. So you feel like that you have some kind of a disorder or a syndrome. Right. So my hands will be shaking. Right. So hands will be shaking and so many things will happen. I think just 2 days back, I think you might have seen in the newspaper, a student got admitted in Mars. Right. So because of obstructive disorder, right. So overuse of the body. Right, so he was on medication for 2 days, but unfortunately on the third day he escaped from the hospital from demands. Right, so why? Because of so much of dependency. Right, so much of dependence. Right, so that's the kind of an addiction. Right, so that's the kind of an addiction. Right, so that's the level of dependency. Right, so it's such a very simplest subject, but you see the level of penetration. Right, so that is the beauty of the synthesis. So overall that you are going to see is all basically the computer. You take irrespective of the data because though I am talking about only medical image analysis, right? So but you find you take any domain or subject for your example, right? So one or the other way, it's always the automation, right? So it's always an automation. So all these things, right, especially the learning took place. Right, so the learning took place, right, so it's only through how we are going to think, right, so how we are going to think, right, so where do we think or how do we think, where do we think or how do we think,
This is very
how do we think? It's a natural phenomenon, it's a natural phenomenon, but how a natural phenomenon takes place? Huh? Right, just throw some answer, there is no evaluation. There is no evaluation, just throw some answer. Look, it happens in the brain. Right, so it happens in the brain. Right, so it's all in one or the other way. Right, so the entire computer science is fully, you know, works upon how the working principles or the philosophies of your brain works. That's nothing else. Right, so why there are 30, 50 definitions for only a word for machine learning? Because all your brains, right, so there are 50 brains, right, so there are 50 brains, right, so all your brains will think in different directions. Right, so all your brains will think in different directions. Right, so that is what actually we are trying to simulate. And each and everything that takes place, right, so that each and everything that takes place, it's all through our brain. Right, so we being in computer science engineers should not really, there is some word called a mind, M-I-N-D, mind. Right, so there is some word called mind. Right, so, and, there are so many things that you can really think of on the same lines, right, so mind and all. Right, so is there any difference between brain and the mind? I don't know the difference between the brain and the mind. Right, so I really don't know about the difference between the brain and the mind. Because unfortunately or fortunately, my wife is a psychologist. Right, so she always speaks from the perspective of mind. And I always be telling from the perspective of a brain. Because I want to know only that how exactly our brain works. I have not seen mind, how exactly the mind works. Right, so and that is part one. And part two is some of the worst cases. I think we might have done, especially the boys who are sitting here. And I will propose you then. I'm actually serious. I will propose you then. Yeah, you are proposing that what you propose or how do you propose? Right, so you say that I am proposing from my heart. Right. Right, so I am proposing from my heart.
Bottom of
Bottom of my heart. That's an amazing experience. Right, so I am proposing you from the bottom of my heart. Right, so if you don't really pick the call, right, so really my heart pains. Right, so my heart pains. And if you don't say early morning, good morning message, my heart pains. Does it feel very sensitive? Does it make any sensitive? So what is your conclusion, friend? Never ever propose to me your heart. Right, so you propose only from your brain. Right, so you propose only from your brain because that is what it is going to tell you. Right, so whether you are doing right or wrong. Right, so that is what actually your brain, that is how actually your brain. Huh? Huh? Thinking from brain will change. To what? What?
That's the wording.
Heart will not change. Thinking, where does this thinking take place? Thinking takes place only in the brain. Heart cannot do anything other than pumping the blood. Heart, really, you just try. Your heart won't do anything other than pumping the blood. If somebody is coming to hit you, right? Does your heart tell see he is coming to hit you? Does your heart tell? No. Who is going to tell you? Yes, very is going to tell you. Right, so and your teacher always behind you, tell you, please use your brain, please use your brain, please use your brain. Never ever your teacher will come and tell you, please use your heart. That takes different directions. Right, so that takes different directions. What is a very interesting characteristic? Brain and reason. More or less, same. Right, so whatever is possible to the brain, almost all the things are possible in the equations. Except for brain is tired. Huh?
Unlimited memory.
Unlimited memory. Right? You answer unlimited memory. Right, so there are so many memories. Right, so it remains so many memories. Right, so everything is going fine for him. Right, so he is really enjoying. The truth, it goes like that. But unfortunately, if he marries somebody else, right, so in the future, you just imagine his life. Just for another 65 years, he should be thinking on that lady. Tell me. We have the program. We have the mathematicians to program all of it.
It loses its memory, sir.
Huh?
But machine memory is always there. You will forget something.
Excellent answer. I think this is the expected answer. That is the beauty of coding. That is the only difference that you can find between the machine and the human brain, or machine learning and the brain learning, is the brain as a capability and capacity, see underlying, that is not really a disadvantage, that is not a limitation. Right, so that is not a limitation or that is not a disadvantage. Our brain has a capability of forgetting things. Right, so if you don't forget, you just imagine, you go back. 3 days back, you fought with your wife. And coming and standing here, just reminding the same thing in the class. You don't forget the things. Right, so you go imbalance. Right, so you go imbalance. That is the only very interesting characteristics of the human brain. And within seconds, you can go to America, Italy, your brain is up. Right, so within seconds, fraction of seconds, can you go to Australia? Can you go to New York? Last place, California? Sitting there, just a second. And the same thing is done by your machines. Right, the same thing is done by your machines. Right, so that's the very interesting characteristics, and that is why, right, so that is why, that is another challenging task that is becoming, especially for the computer science. Right, so especially for the computer science. See, just now we heard, the bell ringing at 2 p.m., 3 p.m. Right, so 3 p.m. But did you notice that there is something registered in your brain? Did you notice? See, some students are playing cricket outside. Are you really bothered about that? No. But unfortunately, your machine bothers. Right, so unfortunately, your machine bothers. See, our brain really doesn't bother about that. Because why? You are interested in knowing what he is going to speak or what he is going to bore us for another 60, 70 minutes. Right, so from now, you are not really bothered about that, cricket playing or the drill that is really at 3 p.m. Right, so that's the only difference. And we are in the stage, right, so which is considered to be the very, very, right, so which is considered to be the very, very sensitive. Right, so one of the interesting and very sensitive discipline in the human nature, right, so in the human, in the human generation, that is nothing but our health. Right, so that is nothing but our health. Right, so there is a domain called medical or the medicine, right, so which is closely associated with all our health activities or the health perspectives, and how exactly we are going to make use of all the learning things that takes place through the machines, and we are trying to apply it. Right, so and we are trying to apply it on this domain. Right, so on the field of medicine, on the field of medicine. And to take it from me, this is the only way, especially in medicine, right, so on the medical or the medicine or the health. This is the only field, right? So where and even the last person in the society doesn't bother. Agree? No, see, I will experience every time going to a medical store and bargaining for a paracetamol tablet. Right, so though it is at 20 rupees, if that means the medical source tells that it is a 25 rupees, without even a single hesitation, we pay 25 rupees and we will take that. Why is that? That is clear. Right, so we are more concerned with our health. Right, so and that is the very sensitive thing. That is the very sensitive domain. Right, so that is the very sensitive domain. And we are trying to play with something called as an intelligence. Unfortunately, that intelligence is artificial intelligence. Right, so unfortunately, that intelligence is artificial intelligence. Right, so yeah, and can you just tell that most of the medical equipment that are available can do the best out of best when compared to the doctors? They can do, but they can do, right? So they can do, right? So, but sometimes they cannot do both. Both are acceptable. Right, so both are acceptable. Right, so they can do, and sometimes they cannot do. Right, so they cannot do both. Why? Because of the sensitivities. Right, so because of the sensitivities. Right, so because that is the level of sensitivity that we are going to see in the field of medicine. Right, so that in the field of medicine. So that we should be very cautious. Right, so we should be very, very cautious whenever we are trying to apply the intelligence which is learned through artificial way, especially on the very sensitive data. Right, so especially on the very sensitive data. Right, so that is why if you just check this, right, so there are some 3 or 4 words that makes it critical. Right, so if I just try to take the title for clustering, can you just tell me the dictionary of the clustering? Group. Right, so grouping, that's the good answer. So then what is classification? Based on functionalities? Ultimately, you will say that is also a grouping. Based on some features. So ultimately grouping. The ultimate grouping. Then why 2 words? Classification and clustering. Why there are 2 words? And if you take any machine learning textbook, right? So there are 2 different chapters for classification and clustering. Why? The way that we are going to learn in classification and do the grouping is entirely different from the way that we are going to learn in the clustering and then we try to group it. Right. So that is the difference between the classification classification and discussion. Classification is very easy because madam said, you know already your what is your name? Pushpa is the name. So who is Pushpa here? Who is Pushpa here? Huh? See? So it's pointing to who is Pushpa madam? She is Pushpa. Why? Because she is already there. Who is Salman Khan here? Oh, one year. I'm asking year. Who is Salman Khan? Who is Salman Khan? Huh? No, because that people is called as Salman Khan. The outside the class. Right. So, but what is your name? Shivu. Right. So Shivu is called as Salman Khan outside the class. Right. So, but do you know the label? No, you don't know the label. So that is why you are not identifying. That is suspect. Right. So why sudden push because she already repeated label. Right. So which is more challenge? That is more challenge. Same challenges. Right. So we don't have any information. We don't have left and right, front and back. Right. So on side things, on the sideways. We don't have any information. But just we are trying to do something. That's just we are trying to do. Right. So without having any information, and that information is called as clear information, or the information which is already known, and that already known information is called as labels. Right, so called as labels. And see, so I told you what is the difficulty that you are going to face in this clustering. Right, so that is grouping. And therefore you are trying to play with the very sensitive data, which is medicine data, the medical data, right? So which is very sensitive. Right, so which is very sensitive. Right, so in that sense it makes more challenging. And then what is medical images? Right, so medical images can be captured in so many ways. Right, so medical images can be captured in so many different ways. Right, so starting from pathological data to the MRI data, to the CT scan data, right, so to the X-ray, the PTI scan, right, so towards the microarrays, right, so because now if you just see from the past 2 days, right, so the entire Kerala state and Karnataka state is, taking a lot of precaution, especially with the new variant of the COVID, right, so especially with the new variant of the COVID, right, so and that is basically medical data, right, so that is basically a medical data, right, so it is extracted from the microarrays, right, so where there is a separate domain called the bioinformatics, right, so where the loads of sequences will be analyzed, interpreted, and come to a conclusion saying that this is the new version of the coronavirus, or the coronavirus diseases. Right, so that is the toughest part of the medical images. Right, so medical images. And here, very importantly, I think we will try to take most of the cases, most of the different types of data that are available in the market or in the literature. Right, so always there is a trade-off whenever you are trying to apply these learning mechanisms. Right, so what is that trade-off? Trade-off is basically the people compromising. Right, so compromising between the accuracy and the time. Right, so compromising between the reliability and the time. Compromising between the security and the time. Right, so but this is one data, this legal data is one type of data where you cannot have any sort of compromise. Yes or no? Right, so that is why in most of the cases, right, so even if you, I think you might have noticed, right, so some of the patients are diagnosed with some of the very, unconventional disease that exists in their body, usually they go for the second opinion and the third opinion. Why is that? Why is that? Because they want to rule out, right, so because they want to rule out that the analysis that they have done is to the expected level, right, so it's to the expected level, right, so that is why you should be really cautious. Right, so that is why you should be really cautious, especially in handling these things. Right, so especially in handling these things. The two the medical images. And then comes the analysis. Right, so what is analysis? Capturing the medical images is one. Right, so then you are supposed to do the analysis. I mean to say, right, so do you think that there are good doctors and bad doctors?
Yes.
Huh? Yes. Right, so as such, I mean, don't take that whatever we see that is happening from past 15 days, that they have, spoiled some of the 900 fetus, are not that, I mean, they are not considered as human beings, right? So they are something beyond animals, right? So we just try to avoid such kind of things. But if you take, right, so when the doctor is going to be called as a married doctor, right, so yes, you have to. So the analysis and the diagnosis goes wrong. Right, so the analysis and the diagnosis goes wrong. Right, so but sometimes it may not be and very intentional. Right, so it may not be and very intentional. When people say that he is a good doctor, if his diagnosis and analysis is up to the mark, but there is an additional component also. Right, so ultimately, ultimately your mindset. Right, so ultimately your mindset also plays a very important role. What is that mindset? Mindset is nothing but you are going to define yourself in your brain. Yes. Right, so I can. Right, so yes, I can. So that is why, so that in most of the things that you might have seen, if you go to that particular doctor, then you feel very comfortable. Why? Right, what is your mindset? Right, so that you create that kind of situation of the scene in your brain, and as soon as you see the doctor, right, so you feel good. Right, so but sometimes the same disease has been evaluated by the multiple doctors, right, so you won't feel comfortable. Why? Because of some other reasons. Right, so because of some other reasons. So that is analysis basically. Right, so that is analysis basically. And both employing the concept of learning, especially as the medical images, right? So to do the analysis, right? So it's a very challenging task, right? So it's a really a very very challenging task. What is this? What is this? There is a table. Right, so it's a brain MRI image. Right, so forget about MRI. Right, so MRI stands for magnetic resonance imaging. Right, so that is basically a physics. And do you know when we studied that MRI? If you just go back to your fundamentals, I think in class 11 and class 12. Right, so again, we all studied. Right, so I don't know. I mean, this generation is much ahead. We all our generation have already studied how these resonance images are captured by using class 11 and class 12 physics. Right, so we've already done. Right, so we are just trying to implement here. We are just trying to use that physics. Right, so and this is the most complex organ that exists in our body. Yes, sir. Right, so this is the most complex organ that exists in the body. You take and go to any doctor, right, so go to any doctor, including the cardiologist, nephrologist, right, so nephrologist, gynecologist, or even if you go to ortho, you go to any doctor, they won't hesitate, right, so to do any sort of an operations on a human body except these patients. Right, so except these patients. Right, so because that is the last organ that they think. Right, so suppose if they want to do operate on this organ or not. Right, so we should be really thankful for this machine learning. Right, so because the days we are there, right, so just you go back to 10 years. Right, so I will see. Right, so most of the brain, operations that have taken place by cutting our skull. Right, so by cutting our skull. Right, so whenever, I mean, it's scientifically proven, right, so in most of the cases, whenever anybody or something that takes place and they touch the brain, right, so that traces remains for the longer. That means to say, you cannot recover at the first time because that is the most sensitive organ. Right, so that is why they don't take a chance. Right, so now we should be really thankful for this 10 years of amazing research that has taken place in the field of machine learning, right? So there are so many, just, bone-based operation surgeries are, right? So they need not look at the cell itself. Right, so something called microscopic operations. Right, so they just use three needles. Right, so needle kind of things. Right, so they just uses the three needles and they can do the operations. Right, so now, right, so most of the things that are happening, especially in the field of, medical, especially in the field of brain, right, so especially in the field of neuro. So directly neurons are connected on the nerves are directly connected to human brain, right? So that is how actually this organ plays a very important role, right? So just seeing this, what can you really draw the inference, right? So but we are the computer science engineers, and if you just give it to any radiologist can present these things. But ultimately, if you give the same image to the neurologist, right? So neurologist can draw some inference on this. Yes or no? Why? Because he has done 6 years of medicine, right? So then another 2 or 3 years of MD, right? So then DM, right? So he has done so many specialization to come to a conclusion. Yes, this brain is in good condition, or it has been infected, right? So or it has been infected. Right, so that is why this particular organ is considered to be a very sensitive organ and it is getting lots of attention, especially in the field of the vision. Right, so this is a sample MRI images that I have shown you. Right, so sample MRI images that I have shown you. Right, so with varieties of challenges. What would be the challenges that you can see? The challenges that you can see is this. Right, so the challenges that you are going to see is this. Right, so see, there are so many challenges that you can see. Right, so especially the capturing this brain image. Here, so if you see, there are two factors. Right, so there are two factors. One is the external factors, and the other one is the internal factors. Right, so one is the external factor, and the other one is the internal factors. Right, so there are so many things, the internal factors. Right, so there are so many things that are taking place. Right, so you are just sitting here. Right, so you are just sitting here, and everybody is seeing me. Right, so everybody is seeing me. Right, so can I really come to a conclusion that everybody is 100% attentive in what I am saying? Definitely not. Right, so I think it's already 3:30. Some of the parents will be more worried about their kids because 3:30 is school leaving time. Right, so whether the kids have come home or not. So that is the first thing that it will be running. And 3:30 for the students, suppose it is a coffee time. Right, so then you will be thinking of your coffee. Right, so you need to take a coffee break. These are all the internal factors. Right, so these are all the internal factors. Right, so which get triggered in your brain. Along with that, right, along with that, something, and the whole body is made out of some chemicals. Right, so the whole body is made out of some chemicals. Right, so why we are sitting, so calmly, patiently, right, so I'm listening what exactly whatever I'm saying. Right, so because there is something in your brain. Right, so because there is something in your brain, and you already decided. Yes or no? Right, so you already decided to sit in this class. Right, so whether you get it or not, right, so whether you won't get it or not, but you have to attend. Yes or no, madam? Otherwise, you won't get the certificate. Yes or no? Right, so you have to attend. Right, so if you don't come, the attendance will be marked as absent. Right, so and that too, if you take your teachers, right, so that is something else. Right, so they'll be on their deputation, including me and them. Right, so we'll be on the deputation. I cannot just say my university that I'm going somewhere and you know that I am top at MIT and going somewhere and enjoying the party. I cannot do that. I need to produce my certificate that I agree here. I have presented something here. Yes or no? Right, so constraints. Right, so they are all constraints. Right, so they are all constraints. So that comes under the internal factors. So that is not only that, right? So then the local body effect, right? So the local body effect means we are sitting here thinking else, thinking something else, right? So thinking something else, right? So why that thinking something else? Because a lot of chemical composition takes place. Right, so lot of chemical composition takes place. Lot of chemical reaction takes place in the body. So that is why when that reaction is making you to sit properly in the class. Sometimes you'll be telling you'll be scolding your teachers, right? I mean your students, right? Yeah, right? So listen, no. Or I get it. Why? Because that is also something an extreme chemical, reaction that takes place in their brain. Right, so it's in the brain. Is that what you want? Right, so everybody will act like that. Right, so then that's absolutely there's no problem with that. Right, so it's because of that problem. Right? And to think about the gray fuzziness. Gray fuzziness is something which really occurs or appears. Right, so whenever there is some compositions, right, so that have not been mixed up properly. Right, so that have not been mixed up properly. So a simple and wonderful example that can be given is, right, so we have three options, or otherwise I'll come like this. When do the confusion occurs in your brain?
Choices.
You're absolutely right. That three colors. Right. So that is the biggest challenge. Right, so multiple options will have multiple confusions in our brain. Right, so multiple options. Right, so we look at the multiple conclusions, and ultimately, at the end of the day, right, so it really matters a lot. Right, so it really matters a lot whether you have taken a right decision or a wrong decision. Right, so and that is one part. And nowadays, we are not really seeing these more options or the selection is bad. We are trying to see the last one, that is something called the uncertainty. Yes or no? There is something called uncertainty. Good example is to have. Right, a good example is did you expect anybody expected to that will die at that when we so engaged? Never, that is uncertainty. Right, so who is responsible for that? Who is responsible for that? Basically, the brain is responsible for that. The brain is responsible for it. Right, so the brain has triggered such a chemical composition such that his heart doesn't work up to the expected level. So that is why there was an arrest. Yes, sir? See the good. Right, so these are all some of the very internal factors in the case. So don't you think it's very challenging task, especially to tackle these kind of factors that are influencing, especially within our body? Is that not? Right, so that is absolutely right. So that is uncertainty. Now, people are not more worried about the percentage. Right, so fuzzy is one thing, right? So where fuzzy is nothing but the conclusion, right? So you have multiple options, either you have three, right? So sir, you have three, you have selected one, that's done, right? So the rest of the life we have to live with that one, right? So you cannot really think of another two. Why? Because they are committed. Right, so because he has committed, that is the fuzzy can be handled to the best extent. But this uncertainty cannot be handled to the best extent. There is a lot of research that is going on, the challenges that are going on, and especially if you are really planning to do your research, right? So especially on the data which comes with the uncertainty, this is the best problem that you can really think of. See, these are all the internal factors. Then what are the external factors? Right, so the external factors, see, noise interference. Right, so noise interference. There are so many things that happen. Right, so something outside, they are not bothered. Similarly, during the acquisition of the image, right, so similarly during the acquisition of the images, right, so I think you might have seen, most probably nobody in this class have gone for the scanning of the brain by God's grace. Right, so by God's grace. At least some of you might have gone for your abdomen scanning. Yes or no? At least abdomen scan. Right, so during abdomen scan, I think your radiologist will tell you drink lot of water, don't pass the urine, don't pass the urine. Why is that? Because they want the clarity whenever the bladder is full. Right, so whenever the bladder is full. Right, so then what do? Once the image is captured, right, so once the scan image is captured, right, so then they send you to the restaurants, you're supposed to empty your bladder, right, so you're supposed to empty your bladder, and again they go for scan, then they take another image, right, so that is the bladder full, and without fluid in the bladder. Right, so they'll get two different images. They'll do some analysis. So similarly with respect to the brain. Right. So similarly with respect to the brain. Right. So in brain, right. So there are so many advanced technologies that they have got. Right. So they use some of the very important dyes. Dyes are basically the liquids. Right. So they inject into the brain and then capture the images. Right. So just to avoid these, external noises. Right. So just to avoid these external noises. Right, so especially if you take the human brain, one of the most fundamental noise that you can see in the human brain is the growth of the noise. What is the noise? What is the size of this one? What is the size of this one? Microscopic. Microscopic is something which we cannot see through our eyes. It is microscopic. Only noise that the entire body can be destroyed only with this small microscopic cell. It is called as what? Right? So now there are so many advanced diagnoses and treatments that are available, but still the level of accuracy that they have made is very minimal. Right. So the level of accuracy that they have made is very minimal. Right. So this is what the challenge that you can see, and then the partial volume effect. Right. So partial volume effect. You just see this last this pointer is not going on this TV probably because of this is a LED. So that is why it is not going on the LED. So the last one, if you see partial volume effect. So whenever if you see me, especially the person who has been accident, he has got a brain injury. Right, so he has got a brain injury. Right, so there will be a lot of the included that happens in the human brain. Right, suppose it is really hurt his brain. Right, so that is caused because of the so many things. Maybe there will be a move out of some chemicals. Right, so move out of some chemicals. Maybe there will be a post formation within 2 seconds post will form because the brain is so sensitive. But if you only are done, maybe you will see the formation of post within seconds. So whereas we take in many parts of the body, right, so the first doesn't form in a minute or in an hour. It takes days. Especially for example, if you see lungs ಅಲ್ಲಿ ಫಸ್ಟ್ ಕೂಡಿದೆ ಅಂತ ಕೇಳಿ everybody can understand Kannada. Right, so that doesn't causes a day. That causes usually multiple days. Right, so but brain within seconds or within minutes, right, so the brain is so sensitive that first will get formed. Right, so that is an external. Right, so that is an external factor, and if that first is formed, right, so then there will be a very challenging task, especially for the radiologist, to capture any MRI CT scan. Right, so these are all some of the challenges that I mentioned. Right, so especially Madam said acquisition of data. Right, so acquisition of data. What's acquisition? Collecting or capturing. Collecting or capturing the data. Right, so collecting or capturing the data. Right, so noise and partial effect. Right, so volume that is present in the brain. Right, so plays a very critical role. Right, so these are the two slides that I wanted to present to you. Right, so just to make sure that the challenges that exist. Right, so now I like to take up the first word of my topic title. Right, so that is clustering. Right, so maybe I take another 15-20 minutes and I'll just show you. Right, so how quickly we can understand the concept of clustering. Right, so concept of clustering. Right, so it's a very simple, very fundamental. I think most of you already know all these concepts. Right, so I'll just quickly run through these slides and you can just really appreciate how these fundamentals can be used to apply or to solve such of the very complex problems like multi-based analysis. Okay? Right. Right. So I think these are all very simple. Example. Right. So most of you might have already known this, right? Learning questions, types of questions, question hierarchical, fuzzy, application, correlated measures, etc. Okay. So whenever I talk something, whenever anybody talks about machine learning, they talk only about classification. It's not only the classification of the question, but there are some other domains that you can really think of. Right. So that is called as an anomaly detection. Right. So what is anomaly? So you said, there is one cell which really makes the entire brain damage. One cell is right. So don't you think that one cell is an anomaly in the brain? That one cell is an anomaly in the human brain. Right. So which takes you so quickly within the span of limited number of days. So the stage 3 or stage 4, and maybe within the span of 6 months, the human will die. Right? So the human will die. Right? So that is anomaly detection. Right? So how do you detect that microscopic cell? Right? So I said inclusion of the pus, your human brain. Right? So how to differentiate between the blood and the pus? Right. So and there is another component. There are so many other components that you can think of. Right. So how do you really differentiate between that? Right. So that is anomaly. Next, you have something called the association rule learning. Right. So that is another very interesting topic that going on in the field of medical imaging. And this is, I think, more or less another 3 years from now, another 3 years or 4 years, right? So you can see lot of association to learning techniques that can be applied in the field of medical images. Because just you want to correlate between different arteries, right? So between different arteries, right? So why do you touch one there? Because of the artery. Right, so why does that heart suddenly stop working? It's because of its brain activity. Why is that brain, reacting like that? Because of something else. Why is that something else? It's because of something else. Why is that something else? It's because of something else. Right, so there are so many interrelated. See, that is why I think most of you might have seen when you go to a doctor, taking your grandparents or grandmother. Right, so most of the time the doctor will ask, the first and foremost thing, whether you have BP, right? So whether you have BP, whether are you a diabetic, right? So are you a diabetic? Why? What is these two diseases are directly related to any type of things? Right. So for a good example, right, so that can be given this. Right. So probably it's just a matter of days. Right. So it's just a matter of days. A patient will suffer with a fever. Right. So the doctor will use different types of paracetamol, different types of antibiotics. The fever doesn't stop. Right. So ultimately, maybe after 10 days or 15 days, it brings a higher level of diagnosis. Still, he is not able to diagnose. And ultimately, the last stage that he is going to put under the diagnosis is what? The growth of unwanted cells in your brain. So, what is unwanted cell? Once again, cancerous. Right, so cancer cell. So now we want to interlink between the different organs of the human body, right, so of the human body, and we want to group it. Right, so yes, based on these things, right, so these organs behaving like this. You need to build the association. Right, so between your blood pressure value, the diabetic value, and to the pulse value, right, so pulse rate value, and to something else. Right, so that is where actually this association rule mining takes place. Association rules also is nothing but it's not something which is a big science that has been introduced in the field of computer science. It's a very simple science that has been introduced. Very simple science. Right, so a good example, why you two are sitting next together? Why you both are sitting next together? Why? Why you both are sitting next together? Because she is your close friend. Huh? Your close friend. Huh? Associate. The correlation is very, very high. Right, so the correlation is very, very high. Why is sitting alone? You don't have any friends here? No friends. So that is true. The correlation is very, very low. Right, so that is why it is usually open. Right, so you see both of them, they are getting to the four, right, so they are very associated. Right, so they are very associated. Right, so that is the same concept that we introduced here. And learning, as I already said, supervised and supervised. Recognition is something. The same lines it goes on the lines of classification. Then you have something called summarization. Right, so summarization and ultimately at the end of the day, so whatever you are going to learn, you need to summarize it. Similarly, is true in an edit command. Right, so the doctor ultimately wants to know that what exactly has been evaluated and diagnosed. Right, so from the different types of tests that are done by the for the human. Right, so this is how actually it goes. Classification, non-exclusive and exclusive, extrinsic and intrinsic. Right, so extrinsic, supervised. Right, so why it is extrinsic? Because Madam Pushpa Madam already said, she is Pushpa Madam. I can remember Pushpa Madam. Right, so till at least till today or till tomorrow. Why? Because I already know her name. Right, so I already know her name. And you can remember me till when? Right, so you can remember me till when? Right, so madam will remember when you till when. Right, so probably she might, might see me I am rolling around the Padres road. Right, so I am rolling around the Padres road and she may tell to her next friend saying that he is the immediate words for almost 3 hours on Monday morning, on Monday afternoon. Right, so maybe another 2 days or 3 days. And after fourth day you ask, break a tea, 15 minutes. We can serve you if it possible. Otherwise, we will not. Okay, I finish this slide. Okay, so that is how the intrinsic classification takes place, right? So that is, but whereas extrinsic, right? So some impact has to be created, right? So some impact has to be created. Right? So even your human brain, right? So we remember, for example, something that you fall during your childhood days. Right, so during your childhood, you still remember. Why do you still remember that? Huh? That is because of the impact that's created. Right, so there is a very high impact, especially in case of unsupervised learning, because it learns without any clear information. Right, so it learns without any clear information. Whereas extrinsic, right, so sometimes it could be a bias. Right, sometimes it could be a bias. Right, so sometimes there could be both the cases. Right, so overfitting cases and the overfitting cases and the underfitting cases also. Right, so that is basically how we are going to formulate in mathematics. Right, so to solve the problem of overfitting and the underfitting. Right, so this is how actually the classification takes place. Right, so then maybe after this break, we'll try to we'll come back at 4 o'clock. 3:45 now. Right, so we'll be back by another 5-10 minutes. 5 minutes. And then we'll try to see some of the interesting slides and take the medical image imaging application. So, before we break, this is where actually we stop. We just try to see the important components of the cluster. The three important features that we need to really concern, right? So with respect to the common cluster, though it study started in the year 1964, right? So where running by supervised mechanism, right? So but still it has got a lot of challenges because of the reason of three important characteristics, right? So these are the three fundamental features that are expected in any questioning or supervised learning method. So one is internal cohesion. So what is internal cohesion? So if you take a group, right? So if you take a group and if you take the people in a group, right? So if you take people in a group, so this is the simplest example that I can give. The same thing can be related to your mental intelligence also. If you take an organ is made out of what? The organ is made out of the multiple number of cells and multiple number of tissues and the muscle and blood, right? So etc. 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 The same thing, right? So if you take the individual cohesion, if you take a group, within the group there should be a high cohesion. Means to say why these four are sitting together because of the high cohesion, right? So because they are considered to be the close friends, right? So because they are considered to be the close friends, right? So that is why they are called as they exhibit the property of internal cohesion. And if you just try to measure the distance between those four, right? So always the distance tends to be very high, right? So because of the reason they are very close friends, right? So if you try to establish or measure the distance between one component to another component, or one entity to another entity, the distance is very minimal. So that is why they always sit together, right? So those four.
Okay.
And then comes the external isolation, right? So but these four, right? So can never ever expected to sit next to your teachers. They don't feel comfortable. Right, so they won't feel comfortable. Why? Because they are students and they are teachers. Right, so they are students and they are teachers. So high cohesion. Right, so that is the external isolation. Right, so that is separation is clearly visible. Right, so the separation is clearly visible. Right, so where in case of the external isolation. Right, so I think if you might have seen this happens. Right, so especially this intra-cluster and inter-cluster. Right, so takes place. Right, so in a very natural way. Right, so in a very natural way. A good example that can be given is you see your students entering the first semester and second semester, first year and second semester, right? So in the first year, right? So you might have seen your students sitting, right? So full one row boys, right? So second row, full one row boys. Here middle, full one row girls. Yes or no? First year, right? So, but if you see second year, right? So maybe of the boys, right? So then of the girls. Then at the back, next three benches will be boys, right? So similarly it goes, right? So second and third year, right? So as well as the placement activities takes place or your the college fest takes place when they come to the pre-final year and the final year, right? So so happens always you see there will be one boy, one girl, one boy and one girl. So that is how they see, right? So that is how they see. Right, so especially in my class, that is what my observation. Right, so whenever they come to the fourth, final year, they are always right. So the pairing takes place. Right, so the pairing takes place. Right, so it's because of this inter-cluster as well as the inter-cluster distance that they are going to keep. And the same thing is applicable, especially in the association rule also. Right, so I was telling you need to find the different organs behavior, right? So within your body, how this diabetic really influence over the blood pressure, right? So over the blood pressure, you need to measure the association between them, right? So how the variation of the blood pressure will affect the diabetes? How what would be the impact if you don't have a breakfast? If you are in diabetic, if the patient is a diabetic, what will be the implication if he doesn't have an early breakfast? Right. So then obviously that is why the doctor will measure the diabetes or the blood sugar content before having the breakfast and after having the breakfast, and you also talk about this average, right? So that is 3 months. That is what the HbA1c is. Right. So that is how they will try to correlate. Right. So and very importantly, they should be homogeneous. Right. So they should be homogeneous. Right. So only in this class You can expect only the boys and girls, the men and the women. Yes or no? You cannot expect any dog coming and sitting in this class. You cannot expect any animal coming and sitting in this class. It is homogeneous. Either a man or a woman is integrated. Either a teacher or a student is integrated. Either a speaker or a listener is integrated. But ultimately, these are homogeneous. Right? So these are homogeneous. So this is the fundamental characteristics that you need to expect when you are trying to work upon the cluster. And this is what the different nomenclature that is given. Right. So very importantly, in psychology, you take it is called as a Q analysis. Right. So Q analysis, Q stands for quotient analysis. Right. So that they try to measure. Right. So in terms of statistics. Right. So in terms of statistics. Why in terms of statistics? Right. So because our brain can understand only the statistics. Agree? Yes or no? Our brain can understand only the statistics. Right, so unless otherwise if you don't give any statistics, right, so no one will really appreciate what the experiments are, what's the results that you have gained. A simple example that can be given, right, so a simple example that can be given, that how you can express, right, so that how you can, right, so who is your favorite actress? Sir? Favorite actress? There are many names or trying to recall? Okay, we'll ask her. Who's your oh, actress. Actress. Deepika Padukone. Right, so Deepika Padukone is the favorite actress. Why? I don't know. See, I don't know. As soon as she would see her, right? So he feels that that's something, that's something your brain maps something, right? So can you really tell how beautiful she is? How beautiful she is? You cannot tell, right? So you cannot express, right? So you cannot express. Right, so maybe you can tell our height is so good. Maybe our complexion, right? So it's so beautiful. A sharp eyes, right? So sharp eyes, right? So our tip of the nose, right? So these are all the things that you can express, but they are all distinct qualitative. But do you like difficult person? You don't like, definitely. But your interest is someone else. Who is your favorite actor? The favorite actor. Yes. Do you like it? No. You may won't like it. So why? Because he has got some, very interesting things. But this is the problem of the another challenges of learning that you can see. Right. So never ever our brain accepts the qualitative features. And the quality cannot be expressed. And the quality varies from person to person. Right. Yeah. It is subjective. Right. So it is subjective. Right. So, and quality doesn't really accepted by anyone. Right. So Shivu has got 9.7 out of 10. So how many grade is it in this sentence? Right? You're thinking he has scored 9.7 out of 10 CGPA. Huh? Excellent. And sir has scored only 4 out of 10. 4. Directly you should say 4. Yes, 4. Right, so why that 4 and excellent? See, there is some quantitative value. Right, so 9.7 is making it to be an excellent, 4 is making it to be an poor. Right, so that is why our brain is more, active with the quantitative values. Right, so that is why we try to think of more of quantitative values rather than the qualitative values. Right, so rather than the quantitative values. Right, so especially when you take this unsupervised learning, especially in case of liquid pattern recognition and machine learning, right, so we try to give a lot of importance towards these quantitative values. Right, so because whatever you are going to see through the data that you are going to see, right, so everything will be converted into one or the other form of analysis. Agree? Because in this sense, very simple. Your machine can understand only the not zeros and ones. It is something beyond your. It can understand only the mathematics. Otherwise, if it is not mathematics, your machine cannot understand. How can the machine can recognize that she is a deep coupled cone? Because of the reason that deep coupled cone has given some mathematical representation. Is that right? Right, so that is why your machine is identifying that she is a deep coupled cone. Right, so we are more worried about the quantitative values rather than the qualitative. Right, so that's the first thing that we need to really understand. So cluster structures. So here there are different ways. There are the you can go for the different ways of grouping the things. Right, so there you can go for the different ways of different things. Right, so some of the things that you can really detect. Right, so clusters is through graphs. That's the most interesting. Right, so that's the most interesting. Right, so why graph? Because I said slowly we are moving to mathematics. Right, so slowly we are moving to mathematics because why? The machine can understand only the mathematics. We have only mathematics. Right, so why graphics? Why graphical representation? It's the most easiest thing that you can understand. Right, so that's the most easiest thing that you can understand. Sir, madam, if I don't say anything else, and if I give this, and if I give this space, right, so for your analysis, right, so I'm giving an input, this space, see, there is a wall here, there is a wall there, there is a wall here, and there is a wall here. There is no door, only this space, right, so only this space, right, so what is this space is called, unless otherwise, if you don't name this space exclusively, otherwise, what is this space is called as? Don't tell me it's a classroom space. Mathematically, what is this space?
What is the extent? What is what is
50%.
Teacher space.
Object size like 3%. Don't go to your engineering school. Don't go to your BTech classes. Don't go to your MTech classes. Don't go to your PhD postdoc classes. I am telling you, go to your class 8, class 9, and class 8. What is this class? No. I'm telling, I'm asking, what is this space called? You are almost there, 50% right. Is that something called x coordinates and y coordinates? This space is simply called as Cartesian space. From where did you study this Cartesian space? Huh? I think solid geometry, trigonometry classes. That is the first space that we our teacher will teach us. Unless otherwise, if this space is not defined mathematically, it is a Cartesian space. ಈಗ ಇವ್ರದ್ದು ತಗೊಳ್ಳಿ ರೈಟ್ ಸೊ ಒನ್ ಇಸ್ ಸೆಟ್ something called x and y. Sir, what is this called? What is this called? No, sir. This is called as a y. And what is this called? X. Right, so x and y. Right, so I am an object now. Okay? I am an object now. Right, so I am an object standing in which space? Standing in which space? Standing in Cartesian space, and I have the x coordinate and the y coordinate. Now Shukasar sir is sitting there. I am standing in this, time, and he is standing in this time. What is the distance that I can measure between that, that person and myself? Sorry, what is the simplest distance from that? What is that? That's it. That's it. This is a very simple thing. Will it be very quickly distance? That's it. See what we can do. See, we can take this all. It's all, that's it. It's all basically 8, 9, 10. Right, so unfortunately, including me, nobody has learned 8, 9, 10 properly. Right, so only when we are doing these things, right, so we got to know it is somewhere else, where? In the class 8. So if I stand here, the distance will increase. If I stand here, the distance will increase. It means to say it's far from me. Right, so if I stand, and if I stand, and if I stand here, my distance will reduce. And if I stand here, we both are very, very close. And if I sit next to you, we both are very, very good friends. Isn't it? That is how actually it is. Right, so that is how actually all your histogram plots, you take scatter plots, you try to take density distribution, scatter plot matrices, everything is analyzed. And now this is a open space, Cartesian space, Cartesian space. Now there is one row of tables, another rows of tables, and another rows of tables. Right, so sitting itself, sitting objects are of two types in this class. One is chair, and the other one is desk. Right, so desk. Right, so you have two types. Agree? One is a male, and the other one is female. Agree? Right? So Pushpa madam, if she comes and stand here, if somebody sees from outside, right, so they identify me as a speaker. And Pushpa madam is a she is a participant. And if Pushpa madam comes and stand here and if I sit there, then Pushpa madam will become speaker and I become a participant. That's it. That is how actually the entire thing goes on. Right, so that is how actually the entire thing works out. Right. There are so many spaces you can sit individually, in the different tables, so you are sitting all four together. Because you are very close. So that is nothing but the density. Right, so that is nothing but the density. Here the density is so good here. Right, so the population is huge here. Right, so in this particular category. Right, so you take this, right, so it is the population is considerably dense. So if you take our base number or test number 5, totally they are weighted. Right, so the population. Right, so I need to, I need to eliminate that unwanted information. So that is basically a noise for my evaluation. If I am interested only in this, so it is an object 1, object 2, object 3, object 4, object 5, object 6, object 7, object 8. That's it. Right, so this is how actually any plots, right? So we will work on it, right? So for example, where did you study this? Multidimensional scaling, right? So multidimensional scaling. So you know this is basically an X and Y coordinates, two coordinates. So if I add the third one, so that will become a Z. Right, so that will become a Z. So they are the 3 dimensions. Right, so they are the 3 dimensions, but I'm not really bothered about only the 3 dimensions. I am really bothered about something else, some multiple dimensions. Right, so 4th dimension, 5th dimension, 6th dimension, but 5th dimension, 6th dimension, 7th dimensions, or 8th dimensions cannot be captured still today for your dimensions. Now your brain can capture only 2 dimensions. That is how your brain has designed. Right, so but your brain has a capability to design to capture the 3rd dimension. That is why you move it. Right, so that is why you move it. Right, so what is basically movie is made of that? No, movie is made of basically images. Right, so it's basically frames. Right, so then suddenly Shah Rukh Khan and Kajol, you might have seen before I the right giant. Right, so they'll meet in London, tubes, that is tubes are nothing but the metro station. Right, so metro station and immediately they go to Switzerland. The next song will be played in Switzerland. So why is that? It is because of the Z component. Right, so it's because of the Z component. But our brain is not designed for the 3rd component. Whereas we are trying to look for the multiple dimensions. Right, so multiple dimensions. And when you scale it, that is the very interesting challenge that you can work on. Right, so that is basically a multi-dimensional scale. But 3-dimensional plots and trellis graphs are giving more out of more best results. But whereas the multi-dimensional scaling is really playing a very crucial role especially in the medical fields. You know the CT scans and MRI scans? You know it's something called, there is a concept called slicing. Yes. Slicing. What is slicing? Basically, they capture an organ. Right, so they capture an organ, they slice it. Right, so they slice it. The first level is gone. Right, so they try to look for the region of interest. They slice it. Right, so again the unwanted information will go. Right, so the region of interest is taken. Again they slice it. Right, so again they capture the unwanted, the region of interest. Right, so they capture, they slice it until they get the region of interest of their own. Right, so we don't think it's a very complex thing to capture the microscopic cell to the image. It's a very challenging task. Right, so that is where actually this multidimensional scaling really works upon. Right, so histograms, when did we study this? We studied somewhere we used graph sheets probably in class 7, class 6 and class 7. We used to plot x-axis, x-axis, y-axis, and then x is so much up, and y is so much, and you draw a line. So that will become an histogram. So that is the same information that you are capturing. So what is this now? See, the red has reached the highest level. What is that? Peak value. So what is that? Any other? Huh? You are absolutely right. That is nothing but you are trying to get the maximum information of that object. Right. So if I am showing, right. So there is a noise. Right. So and if you just try to plot the histogram, it reaches the peak. So it says that my modulation is the highest. So that is nothing but that is what the answer that we get. Right, so the maximum information is captured at the peak. Right, so see scatter plots. Right, so what is this? This is highly dense. You can see maximum, in this red, area. You can see the maximum population. Right, so maximum population. And this, I think, bivariate analysis. What is bivariate? Okay, very simple. As soon as you see this equation, will go. You will struggle with your brain. Right? So as soon as you see this equation, but you think from the other perspective, right? So what is variate? Variate. So what is by? What are the two most simplest variables? So x and so that is what actually I have used here. That is what actually I have used here. Yes or no? See, function of x comma y. Right, so function of x comma y. Right, so with some blah 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 equation. Right, so with some blah 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 equation. So what is that? Whenever you try to change the value of x, you can also see the change in the value of y. Whenever you try to see the change in the value of y, you can also see the change in the value of x. Sometimes you can also keep constant. You can go on varying only the one variable, and sometimes you can capture one thing and you can go on varying the another variable. Right. So this is how actually the bivariate analysis is done. But if you go for the multivariate analysis, there is a concept called multivariate. Yes or no? Huh? Yes or no? Yes. Alright, so you can go for multivariate. More number of variables. It is not only x, y, or z. Right, so you can also add p comma q. Yes or no? If you add p comma q, so always what is variable basically? You try to keep something, right? So which is not common. Variable. Right, so which is variable. Right, so for example, your age is a variable. Right, so it's a variable. Right, so depending upon the age, the height of a person also changes. Till when? 18 years, 19 years, 20 years. Right, so that is how actually the x and y varies. So you try to define more variables. So that will become a new variable. What are the variables? What are the components? Right, so because the impact. Right, so because the impact. Right, so the impact will be huge. Right. So these are the different types of cluster, and just go through this. Well separated cluster will look like this, right? So they are very, very different clusters. And then you have center-based cluster. You take one center and you try to, see the different samples that are captured, center-based cluster, and then contiguous cluster. Right, so where you can see some sorts of an overlapping. Right, so where you can see some sort of an overlapping between and one cluster and the another cluster. But remember, please remember, all these types of clusters should really agree with three conditions. What are the three conditions? One is homogeneity, intercluster variation should be maximum. Intercluster variation should be maximum, and intra-class variation should be minimum. Right. So with the condition homogeneity, right. So with the condition homogeneity, intra-class variation should be minimum. That is, within the class it should be minimum. Between the class it should be maximum. Right. So between the class should be maximum. Right. So now something called nearest neighbor. Nearest neighbor. Let's take example. Nearest neighbor. So the close nearest neighbor is 1. With a green line. The close nearest neighbor to you is the previous one, black color. The close nearest neighbor to you is yellow color. That is the nearest to you. See, the left component is the yes or no? Right, so then density best. Right, so what is density best? Where you are going to see the thick population. Right, so where you are going to see the thick population. So that is why it is called as density based. Conceptual cluster. So this is one of the very interesting clusters. Right, so there you can see some of the overlapping. Right, so there you can see some of the overlapping of the one type of a cluster to another type of a cluster. Right, so one cluster exhibits the property with another class. Right, so with another class. A good example that can be given is a pig. Right, so a pig. For example, in most of the times you'll be telling, right? There is right, so that is basically a concept. Why? Because the property of inheritance. Right, so the property of inheritance. Right, so the kid will inherit. Right, so the kid will inherit the property of the parent. Right, so father or mother. Right, so that is how actually these conceptual clusters are defined. Right, so and it is used to represent a specific type of clusters. Right, so specific type of clusters where there will be an high overlap. Right, so where there will be an high overlap. Okay, so this is basically a data representation that you are going to see in most of the clustering concepts. Even if you take the classification problem, you take clustering problem, this is what you are going to see. Right, so this is a very interesting type of data representation. Right, so probably you might have seen the different types of data representation. Right, so in the first class you are going to see already I have given an example of qualitative and the quantitative. Right, so qualitative and the qualitative. Then if you go one step ahead, right, so there is something called the binary. Right, so there is something called the binary. Right, so there is something called the discrete. There is something called the continuous. There is something called the nominal. There is something called the ordinal. There is something called the interval. Right, so these are all the different way of representing the data. Right, so these are all the different ways of representing the data. Now, what is your takeaway from this slide? Right, so the real takeaway from this slide is, right, so most of the problems, right, so most of the problems will be either looking only towards the binary or the continuous data. You try to explore it from the perspective of discrete. You try to explore from the perspective of ordinal. Right, so you try to explore from the interval. Interval is giving a lot of popularity. Right, so interval is giving a lot of popularity, and that is one of the breakthrough. I can say that where the interval value representation for the data has taken an very important stage in most of the data analytics concepts. Right, so I think you might be very curious. Yeah, this second student of Bapu, right, so this area of work is full and symbolic data representation, where he has used these interval value representation. interval value representation is nothing but you try to identify the minimum value and the maximum value, and try to make sure that everybody or all the values falls within that range. Right, so falls within that range. Right, so but where does the challenge lies? The challenge lies in fixing the minimum value and fixing the maximum value. But you have the wonderful solutions that are given. Right, so maybe I'm looking to his publication, which was done very earlier during the years of 2007 and 2008. Right, so then we explored, I mean, especially myself has explored this interval value representation for the testimony concepts. Right, so and some of my students have explored this interval value representation for the medical images. Right, so especially on the ECG data and the bioinformatics data. Right, so it's included the microarray images and on the brain images. Right, so on the brain images. And also some of the applications also are already available, but you can really think upon to work on those lines. But see, we all try to come out with this pattern because this is the most conventional and the easiest way of representing the data. Agree or not? Yes or no? Because the simplest form of data representation that you can think of to be handled by any machine is the table. What is table? What exactly the table contains? That's the person. Right, so you see here, I have saying capital X is equal to x12 and it goes on up to x13. Right, so similarly x21, x22, x23 goes on. Right, so these are all the different values. Right, so what values? Now I am coming to that particular word there. What is used already? Let's use the word for feature. Right, so let's use the word for feature. Why? Why that feature is important? Because see, we are all basically human beings, agree? We are all basically seeing the two categories of human beings in this class. Agree? One is a male and the other one is a female. How can you differentiate between a male and a female? It's an interesting question. Yes or no? Right, so specifically how I can recognize him as a unique because he has got some interesting feature. How I can recognize Pushpa madam as a Pushpa madam? Because she has got some interesting features. How you are going to see me maybe after one day and still you are able to recognize that he is the person who gave some talk on history, still because of some interesting features that you are going to store in your brain. Yes. Right, so those values are stored here. Right, so those values are stored here. And similarly, you take a image. Right, so you take an image. I'm not really interested in only the medical images. You take an image. If you take an image, what is image is made out of? Pixel value. What is the basic representation that you can think of for the pixel images? Matrix representation. Where did we study matrix?
That's one of the questions. That's one of the questions.
That's one question. No. Still at the lower classes. Right. So we know, I know we took two matrix and we did something called matrix addition. Matrix multiplication. Matrix multiplication. Right. So and we have seen ratio also. See, after all we are playing with the matrix. That's it. We are not doing any extra thing. But here I have captured features, so that is why I have kept it as pattern matrix. But here I am trying to keep the proximity. What is proximity? The proximity is something try to capture the feature as well as you try to measure the closeness between the feature. That is proximity. Whether you can look for the two types of proximity. One is the closeness and the other one is farness. Right. So one is the closeness and the other one is farness. Right. So how close I am related to sir. Right. So how close I am related to sir. Right. So what is the simplest way? Try to apply the Euclidean distance. Maybe I am standing here, he is sitting there. Right. So I am defined with x1 comma y1 and he is defined with x2 comma y2. So what is the simplest Euclidean distance? You apply that. You apply that. Where did we study Euclidean distance? But you won't get the best results of the Euclidean distance because I have not defined x1 and y1 and x2 and y2. Right, so of very interesting. That is why Euclidean distance is not given the distance. Maybe there are so many other distance metrics that are available. You try to make use of. Otherwise, you change x1 y1 or change x2 y2 only. Right. So I have two eyes. Do you have two eyes? Yes. Can I say based upon only the eyes? Can I say is label 1 and I am label 2? No. Right? You think of something else. X1 comma y1. X1 comma y1 and x2 comma y2. So then you will get the more information.
Your line was this line.
This one.
Nice.
So it measures this.
Right.
Yeah, this is a quantified value, right? So when you apply viscosity distance, there are so many distance measures, right? So these are all quantified values. Whenever you apply this distance measure, I am talking only about Euclidean distance. Otherwise, there are in the CV literature there are so many distance measures. Mahalanobis distance measure, viscosity distance measure, cosine distance measure, right? So there are so many distance measures that you can see, right? So you apply that. That is a quantitative measures, but very importantly, you should look for the three fundamental properties whenever you are trying to handle these proximity measures, especially in the or especially in the domain of clustering. Along with the three properties, homogeneity, intercluster variation, intracluster variation, the another three important properties that you should consider is the matrix should be symmetric. Right, so the matrix should be symmetric. No computer systems has designed to handle the asymmetric matrix. Agree or disagree? Agree or disagree? If it is a asymmetric matrix, then what are you going to do? That's the solution we will take. If the matrix is asymmetric, what are you going to do? Correct me. Huh? Make it symmetric. How do you make symmetric? Add zeros. Add zeros. Add the important of zeros. But what is the problem?
Element that
Zeros are not giving any information.
multiplying is not.
Huh?
Multiplying is not.
You do whatever you want. For the matrix, you consider that you do whatever you want. But ultimately, as madam said, these zeros are not really giving any information for you. But ultimately, the machine will accept only the symmetric matrix. So that is challenge number one. Right. So and then and it should be a square matrix. Right. So it should be a square matrix. Right. So always right. So symmetric is nothing but a square matrix. Right. So number of x versus number of y should be equal. Otherwise, you add zeros once again. Right. So what is the number of zeros? Accuracy will be low. Yes. Otherwise, what is the resulting matrix is called? More the number of zeros, and very rarely you are going to see the entries, feature values. Excellent, sparse matrix. Where do we study sparse matrix? When you study? Very fundamental class. Then whole thing was sparse matrix, identity matrix. So these are all the things that we studied in class 8, class 9. Right, so nothing is studied in M1, See, who is using differentiation integration, sir? Are we using really differentiation integration? Whenever there is a concept of gradient differentiation is used. Right, so otherwise, you are still happy and comfortable with this matrix itself. Right, so and ultimately, it should be a non-negative elements. Right, so you cannot say your ice is -1. Ice feature value is -1. No. Right, so you cannot say. You cannot say your height is -1 feet. Right, so you cannot say that your weight is -10 kgs. Right, so these are the three important features that you need to really consider, especially when you are considering the proximity matrix. This is how actually it has been indicated. So some of the distance measures I have already told: Euclidean, city block distance, Minkowski, Canberra distance, Pearson correlation, angular separation. Right, so there are so many things: matching coefficient, Jaccard coefficient, Rogers and Tanimoto.
What is this?
These are all the different distance measures. These are all the similarity measures. These are all the dissimilarity measures. Right, so you can think of both the similarity as well as the dissimilarity. Right. So, but one beauty of this similarity and this dissimilarity, but it's sometimes now it is very popular in the present machine research. Whenever you try to see the most of the works that are attempted, right? So neither they consider only the similarity values, nor they are considered only the dissimilarity values, right? So nor they consider the similarity values. See, while leaving your home today morning, right? So what did you take to your wife? You married? What did you take to your wife? That we'll go to a movie, right? So at 6:30 p.m. If I take class till 6:30 p.m., then can you expect the same similarity value between yourself and your wife? Just imagine the status of his wife. Right, so you cannot expect the same level of affection, love that whatever he got in the morning, right? Because it's already 6:30. The maximum tolerance of patience for an for any lady for the time being could be 5:45. But 5:45, if you are at home, you are done. You are done. You can pass the day easily. If you pass as 5:45, then it's gone. That is true on the opposite side also. It's not only from this side. Right, so then, so similarity and dissimilarity to a certain extent it goes well. Right, so similarity and dissimilarity to a certain extent it goes well. But you see practically, the similarity or the dissimilarity will be always in unidirectional. Yes, sir? Right, so it is always like a gunpoint. Right, so it is always like a gunpoint. I'm taking you to a movie. So you have to express me the full similarity value to your wife. This is the gunpoint. Right, so if you go after 5:45, then he would be on the other side. Right, then he would be on the other side. Right, so but if your wife understand, yes, there was a class till 6:30. Right, so unfortunately it couldn't come. Right, so I am waiting to take me to a movie. Then what is that level of understanding sort of? One. We are giving a quantitative answer. That's one. Otherwise, what is that? Is called as
Uncorrelated.
Highly correlated.
Correlated.
so that is called as the mutual. Right, so that is called as the mutual understanding. Right, so in more technically, the quantitatively, if we are speaking, we will try to estimate the mutual similarity value and the mutual dissimilarity value. So this is the present research that is for them. Right, so and this is very important, especially in the field of medical images. Why? Because the diabetic value should not really impact the blood pressure level, and the blood pressure value should not impact on the pulse rate, and the pulse rate should not really infer something which is not acceptable result. Right, so yes, you should, all the medical image data analysis will agree for the mutual similarity values of the mutual dissimilarity values. So they are called as MSVs or MDVs. Right, so that is the present research that is going on. And choice of proximity measure, right, so strongly influence the choice of proximity measure. The choice of measure should depend on the scale of the data. Okay, so this is how actually you're going to choose the proximity measure. So I just skip all these things. Basically, these are the most two types of clustering algorithms that are available. Right, so which are considered to be very, very independent. Hierarchical clustering and partitional clustering. What is hierarchical? Name itself tells. Hierarchical, hierarchy. Right, so you create a group, right? So at multiple levels. Right, so you try to create clusters at multiple levels. Right, so that is hierarchical cluster. Right, so what is partitional? You try to separate it. Right, so if I see this cluster, right, so if I see this cluster, right, so I can really come out with the 4 clusters for this group. Because cluster 1, cluster 2, cluster 3, cluster 4. Agree?
Yes.
I can also create 2 clusters. Okay? All female, male. All female, all male. Okay? 2 clusters. Right. So still if I go one step ahead, I can create 3 clusters. Agree? 1 cluster, female, second cluster male, third cluster female, fourth cluster male, fifth cluster female, only one. Right, so see different ways of creating the cluster. Right, so different ways of creating the cluster. So that is partition cluster. Right, so usually the clustering is represented graphically through the tree primary structure, and that tree is called as an dendrogram. Right, so that tree is called as an dendrogram representation. Partitional clustering. So these are the differences that you can see. You can just go to Google and type Anil K. Jain and Anil K. Jain and tubes. Right, so DUBES. Right, so you get a wonderful textbook. Right, so that you can refer for your clustering, various clustering techniques. Right, so see with this. Right, so then there are the different levels of clustering techniques that are available. Right, so probably one is the single linkage technique, second one is the complete linkage. How it works, right? So I'll just show you. Right, so basically all this is constructed through using a simple matrix algebra. Right, so we use a simple matrix algebra. Right, so how it can be considered? See, this is how actually the two clusters exist. Right, so this is how actually the two cluster exist, and there are 4 samples that are available in the first cluster, and there are another 4 cluster samples that exist in the second cluster. Right, so now if you try to find the minimum value, right, so see, if you try to find the minimum value, right, so between the 2 samples, right, so then it is called as a single linkage. Right, so then it is called as a single linkage. If you try to find the farthest distance, then it is called as a complete linkage. If you try to estimate the average linkage between a sample to a sample, then it is called as an average linkage. Then, very interestingly, there is a method called Watt's method. Right, so there is a method called Watt's method, which calculates the variance. Right, so which calculates the variance, because variance is one, right, so which we really doesn't acceptable. It's not acceptable, because always we try to intend towards the convergence, right? So rather than seeing the lot of variations, right? So that is why variations are the variance, right? So it's expected to the worst level, right? So it's expected to the worst level. Right, so these are some of the different results that are tabulated. Right, so these are the different methods that are tabulated. Now I take very specifically the K-means clustering. How many of you know K-means clustering? How many of you know K-means clustering? It's a very simple and fundamental clustering algorithm that is available. And if you take, there is a programming language called MATLAB. You know MATLAB? Right, so in MATLAB it takes not more than 3 steps. Under 3 lines of course. Step one is to read the matrix. Second step is to define the objective function, and the third one is to create the number of clusters. That's it. And in Python it takes only 2 steps. Right, so in Python it takes only 2 steps. But what is the beauty of this K-means clustering? The K-means clustering has got a history of more than 60 years. Right, so the K-means clustering has got a history of more than 60 years, and still it is an unsolved problem. Right, so still it is an unsolved problem. Why it is an unsolved problem? Because of so many things. Right, so because of so many things, the first thing that you are going to see, the challenge on the board itself. What is the challenge? Huh? Madam, you said something.
Number of K.
K itself is a challenge. Right, so K itself is a challenge. Sir, how many clusters you want to create in this class? 3 clusters. Madam, how many clusters you want to create? 2 clusters. Good. More than 5, 6. Why you are so frustrated? 5, 6. And then, huh? Okay, so you said 2, 3. You said 3. You said 2. You said 5 or 6. Then anybody from student side, how many clusters do you want to create? K is basically the number of clusters that you are going to create. That's it, nothing else. I try to estimate the mean value. Right, so how to find the mean value? What is mean basically? And it's an average. When did we study to compute the average? Only class in the average. The total number of 600 ratios, the total number of marks that we get, and total number of maximum marks. That is average. Yes, sir? Right. So, and number of clusters. But how many number of clusters you want to create? Anyone? Tell. Only two. Okay. Boys and girls. Or male and female. Okay. But is there any particular case you can create 40 clusters? Huh? It can. Definitely it can. I don't want to get mingled with anybody, sir. Why I should? You are new 5 to 6. In what way you are going to want to create weights? What is the criteria? Students, faculty,
Male faculty,
male faculty, female faculty,
students, male students,
male students, female students. Why so much of structural break? Try to keep your solution as simple as possible. Right, so try to create and keep the solution as simple as possible. Right, so 2 is the best answer. Right, so 6 is the worst answer. I mean, computationally I am telling. Computationally I am telling. Because I am not given any constraint. Sir, don't take it in the other way. You are considered as a noise. Why? You are considered as a noise. Don't take it in the other way. You are considered as a noise. Why? He is happy with that. Right, so he is very comfortable, sir. You are happy with that? And you are enjoying the session? No. Very good. Right, so you are happy with that, sir? Yes, he is happy. So he wants to be another cluster, independent cluster. Right, so he wants to be an independent cluster. So we cannot say, you try to, no, you come and sit here. I cannot impose that. Right, so I cannot impose it. Right, so that is the basic and fundamental problem that we are going to see in this clustering algorithm. So that is why this Anil K. Jain team, Anil K. Jain comes from Michigan State University, MSU. Right, so I spent so many number of years, and they have published one article called as Beyond BEYOND, Beyond 50 years of K-means clustering algorithm, but still the problem is unsolved. Right, so still the problem is unsolved, and that too, especially in the medical images, it's gone. Right, so we cannot really come out of these kind of erratic way of defining the number of clusters as a wish. Right, so it should be very, very precise. Right, so the precision plays a very, very important role, especially in the medical images. Yes, sir? Even 0.001 is not acceptable. Let the time takes very much of time. But I want is so accurate and precise result. Right, so yes or no? So that is what the results that I am expecting. Right, so this is how actually it works. Pass 1. Right, so pass 1. Right, so this is how the another cluster is created. This is how another in the pass 2 is created. So this is the paper that I said, data clustering, 50 years beyond K-means. If you are very much interested, you can read that. Right, so but ultimately, see, slowly I am showing you, right, so that what is the problem that we are going to face with it? Dependent on initialization. Right, and I said, right, so K is my biggest problem. Right, so K is my biggest problem, and how to fix this K value? See, right, so first participant has defined the K value as like this. The second participant has defined the K value of like this. Right, so select random sheets with less minimum distance or run the algorithm many times. What is the simplest way? Which is good, either the first one or the second one? First one or the second one? Select the random sheets with at least minimum distance. Which one is better?
computation plus one.
Second one? In that case, both are worst case. In that case, both are worst case. Because see, select the random series. Right, so when are you going to say that your randomization process is meeting your expectation? Right? When are you going to say your randomization, is meeting your expectation? We never know, right? Maybe in the first iteration we may get the best result, but even if it passes 1,000, iterations, it doesn't converge itself. That is the problem with the randomization. Then if you take the second one, run the algorithm many times, how many times you are going to run? Right, so how many times you are going to run? Each and every time you are getting a different results. Right, so maybe what is the question that you can do? Right, so both are worst, I'm saying. But in the worst, if you want to really find out which is best, maybe the second one is best. The reason is, at least you run for 100 times and you see what is the variations that you are going to get. Try to find out the mean value. That solves your problem. Right, so then you can really at least say that you are trying to capture, right, so within the 100 iterations. But that is not a best result. That is not the best way that you can really think of, right? So that is what actually I've said. But unfortunately, if there are any outliers that exist, then it's still worst case. Right, so if there is a one outlier, right, so in the class, I think you might have seen in your classroom itself, if one student is really troubling you, then the entire class spoils. Yes or no? That is a problem that we are going to face if there is only one outlier that exists in the sample. Right, so this is what the disadvantages that you are going to see, dependent on initialization, sensitive to outliers, right, so sensitive to outliers, right, so can deal only with the clusters with spherical symmetrical point distribution and deciding the value of k. Right, so these are the challenges that you are going to see with respect to the k-weights. Right, so these are some of the difference between the hierarchical versus partitional. Right, so okay. So now what did I say here? Here deciding the value of k is challenging. Right, so what nowadays if you see, there is a huge importance is given to the first word called why? Why? Because we answered already. When does this fuzzy arises in your brain?
More options.
More number of options. See, there is a CCTV. There is a CCTV. It is capturing the data. See, there is a phone. You are capturing the data. Right. So there is a machine. He is recording. He is also capturing the data. Right. So see, within this single room. Right. So within this single room, how many different ways that we are trying to capture the data. Right. So there will be a lot of confusion. Right. So there is a lot of ambiguity that exists in the fuzzy series. See, now we feel little apart. And don't tell me that these things you have not studied in your class 8 and class 9 and class 10. You just take a variable to variable, I understand. That is where actually if I would have presented this as a first slide, right, so then it's really a bounce. Right, so it's really a bounce. Right, so then in order to handle this clustering, right, so we need to go with the soft clustering techniques. Right, so especially this is true in most of the cases with the medical images. Right, so because as I said, medical images if you take an any answer as a sample, right, so it comes with various combinations. It comes with the cells, it comes with the tissue, it comes with the blood, it comes with the blood cells, right, so some important information, some unwanted information, there could be a water, there could be a pus, if it is infected, so many things. There are so many things. Right, so then how to handle this? Right, so now we need to have something called a very important and interesting word. Right, so if you are very much interested, you can just make a note and you can try to explore it. That is called objective function. Right, so that is called as an objective function. So this is the very important, and you know something called the core. Core of any clustering algorithm is how are you going to define this objective function? See, everyone has got some objective here, right? That is basically an objective function. While we are all sitting here, even though it's almost we are tending towards 5 p.m. While we are all sitting here, we have some objective. What is that objective? You want to learn something. Right, so you want to learn something. Right, so you want to progress in your research. Right, so you want to see that how these things can be applied to your research. That is your objective. Yes or no? That is why you are sitting in field 5 p.m. Right, and it should be function. Because why it should be function? Because your machine cannot understand other than X and Y. What is X and Y? No. No.
Variables.
Because X and Y are variables. Right, so because X and Y are variables. So now, can you capture your objective through X and Y? That is what actually we have done here. Right, so that is what actually we have done here. Right, so I have slowly, find you that X comma Y then U comma V. Right, so U comma V. Right, so what is U and what is V? Right, so U is basically a fuzzy partition matrix. What is fuzzy partition matrix? A matrix which is constructed with lot of inconsistency or with some sort of ambiguity. Right, so I'm not talking anything about the uncertainty. Uncertainty is very different. Right, so in the building itself we differentiated, right? What is fuzzy? Ambiguity. If you have more number of options, that is fuzzy. But what is uncertainty? It is totally unexpected. Right, so it is totally unexpected. Either it could be because of the internal factor or it could be because of the external factor. I'm not talking anything about the uncertainty. I'm talking only about fuzziness. Right, so that is how actually you can capture. Right, so now the very fuzzy algorithms that you are going to consider. Right, so especially in the medical images, always we try to minimize. Right, so this objective function according to your requirement. Right, so according to your requirement. So that is what the doctor's job is, right? Right, so doctor's job is always, as soon as he see you, right, so directly you won't give the antibiotics. Yes or no? First day you give with the paracetamol, second day he also tell you to wait for the paracetamol, third day maybe the small changes in the paracetamol dose along with some, painkiller component. Right, so maybe fourth day also if the fever is not going, then we prescribe the antibiotics. But still, after 5 days, if the fever doesn't go for the antibiotics, then we go for the various evaluation. Right. So maybe urine test, maybe blood test. Right. So there are so many different tests that we do. But still, if he is not able to diagnose what is happening, then we go for the multiple tests of an evaluation. Right. So you are just trying to minimize the objective function as in under. Right. So that is how actually you are going to work using the fuzzy series. Right. So subjected to, right. So such that ultimately my objective function should be always equal to 1. Why? Why? Because see, whenever I try to talk something about the fuzzy, and if you represent this fuzzy in terms of mathematics, and to be handled by the machine, what is the simplest way of capturing this fuzzy machine? Excellent answer. What's the answer? So the word that is probability. What is the value of probability? Minimum value? 0. Maximum value? 1. When did we study probability? High school. That's what our teacher tell. Cards are that's what our teacher has taught. Right. So it's all basically the probability. Right. So it's all basically probability. Means fuzzy is nothing but it's basically a probability. Right. So what is the level of ambiguity that exists in your mind, sir? 0.7 means you are in too confusion. Sorry, you are not too confused. 0.2, you are too confused. 1, you have a best decision. 0.5, either you are towards this side or towards that side. This is how actually you can interpret. Right. So always I am telling towards equaling the objective function towards 1. Right, so then how to solve this constraint optimization problem? It is not as simple as we think. Right, so because in the previous example I gave you, right, so for him, he has got 3 options to get married. But you married, sir? You married, you are not married, right? So he has got 3 options, 3 females. Right, so one characteristic that he is going to see doesn't exist in the second characteristic. Second second characteristics, you cannot see the third female. But what is the decision that he can take? Lot of fuzziness. Right, so how to solve that optimization? That is what the problem is. Right, so then, why can we introduce the Lagrangian? Right, so try to use the Lagrangian. Don't worry about mathematics. Mathematics are very, very simple. And whatever that mathematics that exists there is all very simple. The only thing is you just patiently sit and try to look for each and every variable. Right, so the problem is solved. But you try to understand what is the solution. Lagrangian multipliers. Right, so Lagrangian multipliers, right, so if you use the Lagrangian multipliers, the beauty of the Lagrangian multipliers is this. If you use the Lagrangian multipliers, it can normalize. Right, so it can normalize. So that is why in most of the cases, I think whenever if you are trying to have the control over the data distribution, right, so control over the data distribution and try to capture that distribution through some mathematical form, always you are going to use the Lagrangian function. Why is that? Why? What does this law do?
Too much small value
Where is that?
value is too much small.
Ah. Scaling down almost very near answer. Scaling down the normalization bola, it just tries to normalize. It just tries to normalize. So that is the beauty of these multipliers. Right? So then limitations of the fuzzy segments. It's 5 o'clock. Can I go up? It's 5 now. Which kind of 5:15? 5:15 over model.
Bus. So 10 minutes.
Okay, 5:10. I close at 5:10. One phone would be Sharad ke bus is right. So limitations of fuzzy segments. Right. So this is probably I can say this is our own model that we designed. Right. So probably if you just go to Google and type my name, you get all the applications that we have done. Right. So recently, just 2 days back, by using this special kernel for the series, one of our paper got accepted in the IEEE. That is also made available and is freely available if you have an IEEE access at the university or the college level. Right. So, but we applied that to the images. Right. So, then we have considered this microarray images. Right. So, microarray images. Something called lymphomia, leukemia. So that's a type of a cancer. Right, so that is a type of a cancer. Right, so which is where we have analyzed. Right, so where we have analyzed and we have used this kernel fuzzy segments and then we have evaluated. Right, so the problem with the fuzzy segments, conventional fuzzy segments is noise. Right, so it cannot tolerate the noise. Right, so then ignorance of neighborhood information. Neighborhood information also plays a very, very important role. Right, so because why? Unless otherwise, if you don't know the neighborhood information, right, so you cannot go for the better creation of the clusters. Because if he is a good friend of you, right, so then there is no point of going to her to make her as a good friend. Because he himself is a good friend to you. Right, so computationally, you say this would be a better neighborhood to you than that is the worst neighborhood for you. Yes or no? So that is the problem, right? So RSKFCM, right? So opposed to special kernel fuzzy segments, right? So what we did was basically in the fuzzy segments, it was using a very conventional Euclidean distance measure, right? So not to estimate the similarity or the dissimilarity in general sense, the proximity. But here we have used the Gaussian distance, right? So Gaussian kernel. Kernel is what is basically kernel? Kernel is once again an objective function. Right, so kernel is once again an objective function. And then we have incorporated this neighborhood information to the objective function to make fuzzy series as a robust spatial kernel fuzzy series. See, there are two important terms that we play with the two important terms. One is spatial. Spatial information. What is spatial? Spatial is the based on the locality. Right, so based on the locality. And then we played with the kernel. Right, so then we combined the spatial information along with the kernel information and then we modified the fuzzy series algorithm such that the uncertainty is captured to the best extent. So, these are all the set of algorithms that what I am going to propose, that what I am going to present now. Right, so very quickly, they are not only going to capture the fuzziness, but additionally they are also going to capture the uncertainty. So this is the present trend that is going on in the literature of the fuzzy series. In fact, you can just refer this papers that are available. So I just all these things and we have generalized it, right? So we have generalized it, right? So where previously it was only a robust. Right, so robust and it was very specific only to the medical images. Right, so only to the medical images. But here we have generalized it such that you give any type of an images that comes with the fuzzy as well as the uncertainty. Right, so and also additionally the representation also is slightly modified. Otherwise, these results would have not been evaluated to the best extent. Right? So then we have generalized it to result in a new algorithm called as a generalized spatial kernel fuzzy series. So this particular technique we have evaluated in the different domains because of the reason such that it works in almost all the domains to evaluate. One is on the field of intrusion detection system. Right? So maybe we can explore. Anybody is working on networking. This algorithm really gives a tremendous result. Intrusion detection system, and we have worked on bioinformatics, right? So and we have worked on medical images, right? So and we have worked on biometrics well. Biometrics actually we have considered this clear, right? So this clear part, right? So that is where actually we have already published the publication in the field of medical images as well as the biometric. Maybe ideas as well as the bioinformatics you can explore it if you want to really take away these algorithms as an additional things, right? So GSTFC and advanced fuzzy clustering. This I tried to touch upon at the. This I tried to avoid. Right. So then we, as I said, there was something called the symbolic representation concept. That also we worked on the symbolic. So the symbolic representation, basically the capturing the fuzzy and the uncertainty remains same. But what we made was we tried to capture the variations, intra-class variation and the inter-class variation in terms of intervals. Right, so in terms of intervals, right, so such that all the values falls within the range of that particular interval. Right, so that is what actually we did here. Right, so and then for the optimization we used the ant colony optimization. So this I won't touch. And this is what the result that we got, especially in the especially on the medical image processing. VPC, that is basically a partition coefficient. VPC stands for partition coefficient. VPE stands for partition entropy. They are the statistics, right? So they are all the statistics. And VXB stands for Zybin validation metric. VFS stands for Fukumiya-Sugeno validation metric. You need not to worry about too much on this, right? So, but maybe you can worry about RSKCM and GSKCM. And ACO, here ACO stands for ant colony optimization with robust spatial kernel fuzzy sequence. ACO ant colony optimization with generalized spatial kernel fuzzy sequence. And this is hybrid symbolic, and this is mutual intuitionistic fuzzy sequence. With Sugeno and the others methods. What are Sugeno and the others methods? They are basically the statistics, right? So that are meant to validate the level of fuzziness that appears, right? So these are some of the results that are obtained, right? So on the field of bioinformatics. So overall, just I want to show you the results that we achieved. Right, so on the brain tissue images, right, so we started with the implementation of 1999, right, so when fuzzy sequence comes into the literature, right, so and we have implemented and we have evaluated all the results, and the last results that we achieved is 97.62. We started with 74%. The last results that is achieved is 97.62. This is for gray matter. There are three components in the brain. This is for the gray matter cluster. This is for the white matter cluster. This is CSF. CSF stands for spinal fluid, right? So cerebrospinal fluid, right? So and these are the results mean value that we are getting 94.7 and 94.52. This is for the segmentation for the brain tissue images and application of the clustering for the segmentation on the medical images. And we started from the year 2003 and we have implemented, right? So, and we started with something 0.987, right? So, and MSC stands for squared error, mean squared error, right? So, mean squared error, right? So, we should be as minimum as possible and we have reached 0.021. You can just see the precision. Right, so maybe just to summarize, still you have a lot of scope to work upon more than 2.4% of accuracy here. Right, so more than 2.4% of accuracy here. And here I think you can still have a lot of scope, right? So maybe because the medical images expects high precision, right? So which you can take to the next decimal level. Right, so this is how actually you can implement. Right, so these are some of the it's 510. Okay, these are some of the things that we have done. Probably the last part of the variations of the fuzzy sequence, you could refer some of the very interesting articles. Right, so or you can refer our own articles. Right, so you can just go to Google and type my name. Right, so it will take you to my personal website or it will take you to my ResearchGate website. Right, so all the papers are made available. Right, so all the papers are made available. I think there is a lab called CBPR lab at our university. It's computer vision and pattern recognition laboratory. Right, so you can also find all the courses right, that are done and that are kept for the free usage. But the only thing is you need to shoot an email to us saying that you will be using the course. Right, so you will get all the course. If you want to evaluate it for your applications, you can make use of it. Right, so you can make use of it. But only thing is, most of the methods that what we have implemented is through MATLAB. It's not the Python algorithms. Right. So with this, if you have any queries, maybe put one or two questions I can take. Otherwise, you can also drop me an email. Since we are running out of time, it's B for Bangalore, S for Singapore, BS, HRISH. Right. So at JSSST, UNIV.in. JSSS